All right, so we're looking at some applications for these proportions. You know, we cross multiplied. We did do some with scale factor, which is a great application, unit rate, but now we're going to be looking at some geometry and how we can use proportions to help us solve some geometry questions, and then we'll use that and apply it to some indirect measurements, which we'll get to later. A few things of note: when you're dealing with geometry, there's a lot of vocabulary. So a couple of things here that I have. When you see this AB with a line over it, what that means is we have some line segment from A, and you don't have to write this down, you can just watch right now, to B. So that's a line segment AB. And that's what that means. So AB with a line over it means line segment AB. AB with no line over it, so like this right there. AB with no line over it means that we have taken some kind of a tool, like a measuring tool, a ruler, a tape measure, and we have measured AB. And so you might say that AB, the picture, is right here. That's AB with a line over it. That's the picture. If we measure that, we might say that AB equals, I don't know, 5 inches. And so the only difference is that line represents the picture. No line over AB represents a number. Similarly with angles. Angle AB is with that angle symbol right before it. This symbol right there is an angle symbol. It means angle AB. And if we measure that angle, if we use a protractor to measure that angle, we would say that the measurement, M angle A, the measure of angle A might be like 40 degrees. So if we have this angle here, we'd call that angle A. And if we measured that angle, we measured from here to here with the protractor to figure out how big that angle is, we could say the measure of angle A equals 40 degrees. And so that's just some notation pieces. So when you see that M angle A symbol, you know what they're talking about. It's the measure of angle A. All right. We're going to be looking at similar figures in this section. Similar figures are ones that are not quite the same. We have two triangles. They look almost the same, the difference being that one's smaller than the other. And so we would call these similar figures, similar triangles. And there are a couple properties of similar triangles that we're going to be using to help us. One property of similar triangles is that we have similar figures in general, is that the angles, the corresponding angles, the angles that match up are equal. So if I look at angle A here, and I'm going to put a little arc underneath angle A. Angle A matches or corresponds with angle D. And we would say then that the measure of angle A is the same as the measure of angle D. They match, they correspond, and they are the same. Now A and E, angle A and angle E, they don't match. So they're not the same. But angle B, and I'm going to use two arcs to represent angle B. Angle B matches with angle E. And so those two are corresponding angles. And then, of course, the last one, C and F, and I'm going to use three arcs for C and F. Angle C and angle F, they are corresponding angles as well, and they have equal measurements. And the way we would write that, and I'll have you write this in as well, is that the measure of angle A equals measure of angle D, measure of angle B equals measure of angle E, and measure of angle C equals measure of angle F. The corresponding, the matching angles are equal to each other. Okay, you can pause that, write it down. So the measures of those angles are equal and are the same when we have similar figures. Another property that we have to help us with these triangles and help us use these triangles to answer some different questions is deals with the side lengths. So I'm going to just throw some numbers in here. Let's say this side is 4, this side is 3, this side is, we'll go 15, and this side is 12. Go ahead and write those in. If I want to figure out how long the missing sides are, one thing that works with similar triangles or similar figures in general is that the side lengths are proportional. What that means is that 4 and 12, the corresponding or the matching sides, this side here, AC, matches with side DF. The corresponding sides have proportional sides. So that means that 4 times something will give us 12. Well, 4 times 3 is 12. So that means that all the other sides hold the same proportion. Basically, it grows or shrinks at the same rate. And so from 4 to 12, it's 3 times as big. So the triangle DEF is 3 times as big as triangle ABC, and all the sides have to have the same proportion. So if 4 times 3 is 12, 3 times 3 is going to give us 9 for side DE. So side AB and side DE are matching, they're corresponding, so it has to have the same proportion. Similarly, from CB to FE, if I know FE is 15, then CB is going to have to be 5, because CB has to match or correspond with FE. And so that proportionality is something that we're going to use. We're going to have you write this down. That's exactly what's written here. That if you take side AB, which we said was 3, and DE, which we said was 9, that's 1/3, which is the same as from BC, which was 5, and DE, or EF, excuse me, which was 15, that's 1/3, and AC and DF, 4 and 12, that's 1/3. So they're all equal. They have that same proportionality. So go ahead and write that down. Okay, I'm assuming you wrote it down. We're going to move on. There we go. Let's use that proportionality to help us find some missing measurements. So we want to find the value of x. We don't want to find x. Notice it doesn't say find x. So on a test, I don't want you to circle it and say, right here. That's not what it says. It doesn't say find x. It says find the value of x. So we are going to try and figure out how long x would have to be, how many centimeters. And we can use some proportionality to help us with this. So, did I skip a page? I did. I'm sorry. I will put this in here too. Again, some notation, some vocabulary. This tilde sign, a little squiggly sign there, that means similar. So we would say that triangle ABC is similar to triangle DEF. And that's what that notation says. That tilde sign, which is, if you're looking at a keyboard, I think it's the top left-hand corner. But that tilde sign means similar to. And one thing you have to be careful of is it would be correct to say that ABC, triangle ABC, is similar to triangle DEF. It would be incorrect to say that triangle ABC is similar to triangle EFD, as it states right here. That would be wrong, because A matches with not E. A doesn't match with E. A matches with D. And B matches with E, and C matches with F. And so the corresponding angles need to be in the same order. And so we would have to be careful and make sure that they are in the same order. We'll see how that applies in a second. All right, so again, we're back here. We're trying to figure out the value of x. I know that triangle MNP is similar to triangle STU, STU. And so if we're looking at side X, here's side SU there, SU. So the side, or us, side us. SU, or US, is at side X. And we are trying to figure out how long that is. Looking at those two triangles, I know that side MN is the same as side ST. Or they correspond, excuse me, they're corresponding sides. MN and ST match. So MN is 6. ST is 4. I also know that side SU must match with side MP. First and last letter, first and last letter. So here's MP. So they match up. And I know based on what I wrote down right here that the corresponding sides are proportional. So I can set up a proportion. I can say that 4 matches with 6, which means that if 4 and 6 are proportional, they have to have the same proportion, an equal proportion, as x and 14. One thing to be careful of is pick a direction, left or right. I read from left to right, and so when I'm doing these problems, I'm going to go from left to right, and then from left to right. And I'm just going to keep reading from left to right. So when I do 4 over 6, I'm going from left to right, and I do x over 14, I'm going from left to right. Now that I have a proportion, I can solve. I can cross multiply. 4 times 14, 6 times x. So 4 times 14 is going to give me 56. And 6 times x is just 6x. I divide both sides by 6 to get x all by itself. There we go. 6. 56 divided by 6. So I could use a calculator and figure that out. It doesn't say to use decimals. But I can also know that 56 or 6 goes into 56, some amount of times. I don't know. My brain just kind of went and died on me. What would that be? 8 times? Yeah, 8 times. So we'd have 48. No, 9 times. Sorry, 9 times. And we'd have 54. So 9 times with 2/6 left over. So it'd be 9 and 1/3. Whew, that was a long process. 9 and 1/3 centimeters. 9 and 1/3 centimeters. Again, if you used a calculator and you saw that it was 9.3 repeating, we could certainly say 9.3 repeating centimeters, and you'd have the same answer. So again, to set up the proportion, read from left to right, match up the corresponding sides, the sides that match, and then cross multiply and divide. Try this one on your own. Find the sides that match, set up a proportion, cross multiply and divide. I'm assuming you tried it. I'm going to put the answer on the board. If you don't have the same answer as me, make sure you look at the linked video. In this case, x, or the value of x, is going to equal 2.8. And again, we should be labeling inches. If you didn't get that, watch the linked video. Next one, try it. See if you can get the right answer. I'm assuming you tried it. Even if you get the wrong answer, try it. If you tried it and you have an answer, then you should keep watching. The correct answer for this one, x is going to be 2.5 inches. And if you didn't get the right answer, make sure you watch the linked video. Last one here, there are 2 variables, x and y. Be careful, this is a trickier one. We're building into this process, and we'll address it in class 2 if you have questions about it. But try this one on your own. I'm assuming you tried it. If you get one of the correct answers but not the other, please do watch the linked video so you can see how to get both of them. The answers for this one is that x equals 12 and y equals 6. If you did not get both of those correct answers, make sure you watch the linked video.